Welcome everyone. Thanks for tuning in for this talk. Today I'm going to discuss about the new display infrastructures, the current changes being done to the infrastructure and the architecture, and say a few words about some potential future work. My name is Marius Vlad. I've been at Collabra for the past 1.5 years, mostly working on Western and Wayland. Extended some of its debugging infrastructure, improving the way libwestern makes use of the hardware planes exposed by the display unit, such that provide clients the ability to do direct scan out of its buffers. Looked into different tools for writing documentation. In terms of agenda, I'm gonna go over major changes being done in the display architecture and infrastructures. In terms of the compositor and application conversions, I'm going also to touch some of the areas that need more work, further refining, and even functionality. So, major noticeable changes is the fact that we no longer use Western, but instead we now have a compositor based on libwestern. With that is that we no longer use IBI shell, but instead rely on XDG shell. In terms of applications, they do not require modifications except for the HMI and those wanting further window management interactions. For the life cycle of applications, some of the components will no longer be used. One of those is the window manager. And lastly, we provide additional functionality by using private extensions, which is a common thing happening with Wayland compositors. This is due to the fact that XDG shell is suitable more for desktop-oriented environments rather than AGL, which targets automotive. So the AGL compositor is the new compositor. It's the same as Western, being a user of libwestern and libwestern desktop. Internally, it encapsulates the notion of an output. It encapsulates the Western compositor and the surface objects. I would say the major thing with the compositor is that it uses the libwestern desktop API, such that it provides some specialized implementations as to handle XDG surfaces transparent for applications. So the IBI shell to XDD shell transition. So XDD shell is maintained by the Wayland community, and it's rather mature now and stable. It is suitable for desktop-like functionality. Toolkits like Qt and Chromium would implement the client side, which obviously is transparent for the toolkit users, and for the compositor we make use of libwestern desktop to implement the service side. This picture shows the two ecosystems currently used by AGL. Qt and Chromium being the toolkits for writing either native applications or HTML5 or web applications. The arrows signify the Wayland protocol, the black arrows, while the red one exemplify the private extensions interactions between different components. The bits in red or orange are those maintained by AGL, those in green by the Wayland Western community, and those in blue are public APIs. One thing to note on this diagram is the stack where clients need to add or implement the client side private extension. So for the Qt, you see that the home screen HMI will bind directly using the Qt Wayland Qt platform abstraction mechanism to get a hold of the display handle, while for the Chromium Ozone Wayland side we need to provide implementation for the private extension at that level, and not like something equivalent would be the web application manager. This diagram is also available in the documentation for the AGL compositor if you want to look at it more deeply. In terms of the private extensions, so XDG shell is perfectly fine for the desktop, but it lacks some of the functionality necessary in AGL. And it's quite custom for Wayland compositor to provide additional private extensions as to customize their behavior even more. All major compositors do this. We have Wayland extensions, we have the Wayland protocol itself, but we also can make use of private extensions to even add more functionality. In AGL we have two extensions. One, which is you'll find this also in desktop environments. It allows to set background panels and perform surface activations. It delays presentation until the client will notify the compositor that okay, I'm ready. You can now start displaying me, and it also handles activations. Now, it turns out that AGL shell, AGL project, some of its applications require the ability to, for instance, activate or hide themselves, or we want some dialog pop-ups type of windows, and for that we added another private extensions, and this private extension has three major roles. It can perform activation, deactivation. It receives events back from the compositor when the surface was created or the surface has some state change, meaning that it's either activated or hidden. And we can hint the compositor before surface creation that the window itself would be like a dialog, or it would be a split one, or it should be started on a different local output or a remote one. I have here a diagram which shows how surfaces are being stacked into layers and how these layers are on a different z-axis order. So on the left you'll see the HMI with different distinct surfaces, each assigned a different layer, and these layers are similar to the IVI layers, such that they have different stacking position in terms of their z-axis. Regular applications will be stacked on a layer, or one on top of the other, with the private extensions allowing to switch between these surfaces by removing the current one and from the layer list and replacing one with the one desired. So I've also included here the AGL shell extension, which shows the ability to have split surface or the ability to have dialog and pop-ups. The dialog pop-up is a bit a thing on its own, because it's actually a top-level window. You can put anything you want that. You can position it independently. It will always be in a layer above all the other layers. These layers are Western layers. So activation, like I've said, it also happens from both extensions, presumably, and an update on that would be to use just one of the private extensions to handle that, but that's more in terms of refining the protocol. In terms of application lifecycle, unfortunately there's nothing really defined in the AGL project. Window Manager took that role. So the startup of application is being handled by the home screen library and binder. That will verify that the application is started, and if not, it starts it. Next time you're going to activate this window, it will see that it's already started, and it will not do that. In terms of surface activation, that was being handled by the window manager and the binder. Now the window manager will no longer be needed, neither its binder, so the activation was being handled directly by the HMI with the AGL shell private extension, or by regular applications that bind to the AGL shell desktop private extension. In terms of application conversion, home screen obviously binds to the AGL shell private extensions that allows it to set panels and backgrounds. Now, the diagram showing the HMI and its distinct surfaces means that we have a one-to-one mapping from a surface to a QML, but actually it's the other way around, from a QML to a surface. And the home screen has a bit of work done into this this thing to separate that big surface into distinct QMLs, and use the QMLs to create distinct surfaces using the private extension. For clients launcher, for instance, uses the AGL shell desktop to activate other applications. Home screen starts them, and the private extension activates them. Alexa Viewer needs the ability to hide itself, so it also binds to the AGL shell desktop private extension. TPT Navi would like to be displayed on a different output, or potentially a stream one. So it uses the AGL shell desktop extensions to set itself as a remote kind of surface. One thing to note, and this is rather important, is that we need the ability to identify between applications. The activate request from each of the private extensions will need to somehow identify the surface, and in order to identify it, we need to give it a name. Toolkits have the ability to do this. Underneath, this translates to the HDD shell set application ID requests. All applications have this thing called added. I guess the last thing that I've noticed with the QML changes is that most, if not all, had hard-coded width and height. So we now make use of the window size, giving back by the compositor to add that in a more dynamic fashion rather than hard coding the values in the QML. In terms of ecosystems, for gaining access to the request exposed by the private extensions, under Qt Wayland, we use the Qt platform abstraction, which allows us to gain access to the Wayland display handle, which will in turn allow us to search the registry advertised by the compositor and bind to our private extensions interfaces. Now for Web Application Manager, things are a bit more convoluted, as the way that Web Application Manager is built on this modified version of Chromium adapted for the WebOS. The client-side implementation are actually hidden by different layers of abstractions until it reaches the window layer management layer in the Chromium called the ozone part. Ozone, it interacts with X11, with Wayland, and presumably other window system out there. So I pretty much had to plumb quite a few levels of abstractions, which will give access to the surface, which backs up a web page instance, which is like a web application manager representation of a web application. Well, I also had to add the setup app ID request in the XDG shell, because that was missing, and we pretty much need that to identify applications. The last thing that needs to be mentioned is that the older window manager had this policy manager baked inside its library. The idea is to provide something similar. By no means this is the same thing as that one, but the idea is that people create a specialized version of these, and we call that a policy engine. It has two major parts, that is hooks, and these hooks are installed at different points in the compositor when the surface is being created, activated, for instance, and we have a mechanism to insert data back into the policy, depending on some predefined states and events, but these states and events are actually added dynamically, so you can create new states and events. I'm going to talk about that a bit more. In terms of hooks, surface creation, surface activation, and activate by default. This activate by default is actually a feature. Applications start and it seemed nice to show them show their surface as they started, but you can control this by not allowing that to happen by using these hooks. Hooks are also added when trying to bind to the private extensions, so you can control that. You might not want all applications to be able to activate or hit other applications, so that should be able to control that. And obviously data can be injected back with those states and events. Here's what I mean by that. So the idea is that you have this kind of scenarios where you would like to show the application app when the car is in reverse in about in a second. The thing to note here is that this only adds a policy rule, does not apply it, so there is another function which pretty much signals the policy that it would need to see if there's something that needs to displayed to happen, or there is a timeout, and try after that timeout to perform one event has changed the state. So as long as there is no state, there's no event happening, there will not be any way to signal back to the policy that something has been modified. In terms of future display changes, input and output manager. The input and output manager for the input bindings, thing is that we only support application of key bindings, and we need some helper modules to gain access to the CAN inputs. We also need to see how can we refine input handling for different use cases, especially for remote CAN controllers such as the BMW iDrive. For the output manager, we currently have static configuration files, but we would need some way to do to do dynamic output for the remote displays for being added and removed. Slightly related to this is the fact that the policy API needs to be a bit modified so it can drive different policy decisions, as to in turn see if we can apply that policy in terms of do dynamic outputs. Now, for the policy, we will have two policy engines. One is the default one, and one is the deny one. The default all policy. Sorry, that should be allow all policy and not default. It turns out that this allow all policy is the default policy by the compositor. So that basically means that all applications are permitted. Now, the deny all policy has a static list of permitted applications, but we should try to make use of the SMAC labeling system security mechanism and application framework to dynamically add applications. I understand that we might have a token mechanism, or at least something else, such that it would be much easier to write an application, create application framework configuration XML file, and from there to derive some SMAC label that will be added dynamically to a list of permitted applications. Waltham integration. Waltham is a network IPC library. It resembles Wayland. It's described using XML the same way as the Wayland extensions are. The idea is that the compositor should be able to load it as a plugin. I understand that there's also some more work needed for supporting different backends, but technically technically shouldn't be that of a problem if it's like the remoting plugin. We can load it up and use the API itself. There is quite a bit of work regarding the web application manager and the ozone chromium. So far I only added support for the AGL shell. The question is that if we should add the AGL shell desktop. At this point I don't think so, but I'm not entirely sure. For activating, we require an explicit output being handled. This is being abstracted in the HMI home screen dashboard by using the primary screen, but we actually need an explicit output being stated when doing those requests. I pretty much use the XDG output private extension, which is implemented by the Qt Wayland client side as well. So the idea is to use the same thing here. It would make interaction with something that is similar to home screen in terms of HMI, and presumably for other applications, so we don't need to plumb again all the bits in the ozone Wayland to gain access to a valid output. And the most important thing is that the web application manager requires some redesign to be able to handle multiple surfaces the way that home screen does now, because apparently you have web page surface, it's one-to-one but you also have a web application manager instance per web page, so you'll need for this normal use case where you have top and bottom panels, you need to have a background. You will need 3 web application instances. You need to start it 3 times, which is suboptimal to say at least. So we need some redesign on how web application manager deals with many web page and multiple instances of itself. It's not that complicated, but yeah, it requires a bit of work. One thing that was mentioned in some previous talk was some command line tool for interactive interactions. Now, this, from what I understand, this should be similar to the way Layout Manager pretty much works out, and we can probably have an extension for this purpose, which will call into different bits of the compositor. But I'm wondering if this is actually for development or actually for testing, because for testing there are better tools for doing that. The Western Testing Suite recently got the DRM backend support, is able to use the GL renderer for the headless, and should be much more or better targeted than having this command line interface happening. Just a small note here. The compositor, like Weston, is capable of being run in different backends. You can actually run X11 and then start the compositor, write your UI using the toolkit. Obviously, you will need to have the same versions that you use on the board with the one locally to make sure you're using the same Qt, like for the same Qt version, to avoid any potential problems, and that will be just fine. Obviously, any application framework integration, you also need to add that. I understand there are some repositories. I know that I've used that, but quite limited. But it is possible for you to write and use a local machine to prototype and then deploy on the board. An idea that you will need some tool to try to adjust the window size or try to move it to a certain position and see how that looks like. You can actually do it much faster on a local machine prototyping there than doing the deploy and then to try to figure it out if this is aligned to the correct pixel width or height. Anyway, I guess there are also some design and architectural changes. We would like for people that want to modify the compositor not to spend too much time finding what they need to modify, and also avoid breaking different other components. So for that, we would like to have some clear separation of components. That's why we were using something manager. I guess we need to do more work towards that part. Another idea would be that to have some front-facing libwestern API. This will allow us to have some intermediary states to be used in the policy hooks. The policy hooks are not reactive, while you can modify the internal state of the compositor using them. If you're going to have another request that does pretty much the same, that will not be that good. So front-facing libwestern API would provide some API to avoid that, but also if there are any changes in the libwestern to hide those modifications. And finally, some miscellaneous items, that is the integration with the CI, and try to use the Western testing suite, and obviously more documentation. And that's about it. Thanks for tuning in, and if you have any questions, I'm here.